Oh wait. Let me put it over here, folks. That way it doesn't get feedback.
I was wondering if you pick do you pick up a tap?
See? So you're broadcasting.
Do you hear that?
Oh yeah, it takes a bit.
You hear that? Okay. Is it still staticky though?
I must have done something.
That's good. As long as the static's fine. You hear that? Okay. Is it still staticky though? I was gonna say I hear myself. How am I hearing me? As long as the static's fine. You hear that? Is he gonna be at the podium or is he gonna be? I was gonna say I hear myself. How am I hearing me? As long as
No.
Is he going to be? If you go wide out though, you can get him either way. Then you get everything. I wish I brought my glasses. This camera's nice. Is he going to be? If you go wide I want to try it this week. Then you get everything. I wish I brought my glasses. This camera's nice. We could, I suppose, because it records as a stream, right? Then you get that right? Will it work to our site though? This camera's nice. Okay. But you were saying you were having because it records as a stream.
Yeah, things like that.
Let's do that. All right, so let's do that next week. We'll stream the thing. But you were saying I should. When I play Final 13, I always. Really? All right, so you can stream at 1080 next week. Really? Stream the thing.
Well, I got the horsepower.
Yeah, I don't know if you want to just straighten out. So you can stream at 1080
My only,
next week.
yeah, see, it has to. Well, I got the horsepower. Get a little.
So there's a level there right on the front. Yeah, I don't know if you want to just see that green down to go on the other side.
Yeah,
you see that? So we got to go up on one side.
Get a little.
So there's a level there right on the
that's
front.
right.
Yeah,
Yes,
yes.
right
See
back.
that green down to
There
go
you
on the
go.
other
There
side.
you go. Look at that.
See that? So up on that side. Okay. Oh, there's a level there.
That's right. Yes. Right back. Ideally like that.
Right there.
Yeah.
So that looks good. Okay. So they're gonna lower this down.
Ideally like that.
Right there.
Yeah.
So that looks good. Okay. So they're gonna lower this down.
I hope so.
Right there. That looks good. So are they going to present it?
Yeah. I hope so.
There, I locked the head and everything in place. So are they going to present it?
Yeah. That's probably got a good idea. That's probably got a good idea.
There, I locked the head and everything in place. So are they going to present it?
Yeah. I gotta. Probably got a good idea.
There, I locked the head and everything in place.
You gotta like that.
What you got?
Yeah. I gotta. Probably got a good idea.
There, I locked the head and everything in place.
You gotta like that.
What you got?
Yeah. I gotta.
There, I locked the head and everything in place.
You gotta like that. Yeah, don't go far.
Over here. No, this guy.
Oh, he's, remember Paul Duffy?
Yeah, yeah.
He's his replacement.
Oh, okay.
Yeah, he's why I called the other day. That's my real feeling right now. After you told them. Like that. Well,
It's live.
yeah, awesome. Yeah, because originally, what was going to happen where the cooling was, it was going to report that, but I guess they wanted to add more blemish, so they added the podium. That's what it's called. Podium. It was. Ourselves.
Oh, okay. But that's not recording right now. But that won't be on the final cut, right? Cut down. Okay. So you cut like all that.
The YouTube editor will let you cut.
So what's it going right now? Because I see Rajiv there and circle.
Probably just with bluff rate. But it's streaming. Definitely streaming.
All right. Well, I'll go learn at Bridge now.
That's good.
Because you're going to 3. And then you have five
Just be out somewhere.
All right.
Like I said, I'd love to be there.
Hey, if I don't see it, I'm working on soccer tournament.
Really?
Love that. It's, they call it a fun day. It's for 8-year-olds and 10-year-olds. Come in, just have fun. You know, don't keep any standings. Yeah, don't keep any standings and all that. But I got 2 food trucks coming. Breakfast truck, ice cream truck, pizza truck.
Do a lot of kids tennis?
We have 30 teams, so 300 kids, 2 days, family. So altogether, just under a dollar.
Favors all over town.
Actually, we spent about I mean, profit.
Good luck. I'm working. Oh, you actually work with
There we go.
We'll have the candy, chips, Gatorade, coffee,
And walk it.
We got chili. We talked about it. I didn't want to take away from you. We only got
Professor Gonzalez. Huh?
He said tense advance.
Oh, no problem. How do I say no problem in Hindi? Like, oh my God, thank you so much. No problem. Oh, there's no direct translation.
I'm tentative because I don't speak Hindi enough so that it will come immediately to my mind. So I would say, what would I say in this situation?
That is nice. You say, oh, no problem.
No problem. These days, because so many people, especially the use a combination of Hindi and English, so they would say, "Koi problem nahi hai." There's no problem, which is nothing. So you would use some words of problem is what I mean,
Right.
but it's understood by
Hindi English. Okay. That's interesting.
find your way to a seat, please. If you could have everyone find a seat.
I say you came all the way from Windsor. Where's my email? Can I get out?
Hello, Orlando. Good to see you.
Good to see you as well, sir.
Taking some good pictures.
Yes, yes, sir. Are you taking yours?
Good afternoon. It's a pleasure to welcome current and former students, current colleagues, alumni, members of Krishna's family. I'm so glad that you could all join us as we are here to celebrate the appointment of Krishna Pattipatti as our latest Board of Trustees Distinguished Professor. It is the highest honor that the university confers upon faculty, and I would like to invite Provost Jeremy Teitelbaum to say a few words about the award.
Well, so thank you very much for this invitation to be here today, and congratulations on your selection. As Rajiv said, this is the highest faculty honor that the university bestows. It restricts the number of them, and people who are selected for this award go through a very competitive process, selected by their peers, who collectively are an extremely accomplished group of faculty who span all the disciplines of the university. So you are joining a very distinguished club, and I'm sure they will be delighted to have you. I'm looking forward to this. I took a minute to look. I had never met Krishna before, and I took a minute to look at his CV, and I didn't leave enough time, actually, because it's quite long, but clearly a very fascinating and wide-ranging collection of interesting problems. So thank you very much for having me. Congratulations to you and to everyone here who is sharing in this event.
The Department of Electrical and Computer Engineering is committed to its pursuit of excellence in all three domains of teaching, research, and service. And at every step of the way, my boss, Dean Kazim Kazrunian, has been right there to help us as we need it. Kazim?
Thank you, everyone, and Krishna, congratulations for this very well-deserved recognition. when we celebrate an excellence in a colleague, somehow we take ownership or co-ownership in that excellence. And I've known Krishna for more than 3 decades now, and we have been in various committees together, and we have discussed different initiatives, and over the last 5 years or so, we worked much closer to develop the UTC Advanced Systems Engineering Institute, in which he was a founding director, executive director. But when you really think about it, and when you trace excellence in various people, although they have to have the intellectual workhorse, and they have to have the passion and dedication and the hard work that goes with it, but in every person you find the trace of an underlying feature. And again, the way I have looked and I have known Krishna over the past few years, excellence in him is not probably a skill set, but is more of an attitude and demeanor to things. And if I want to cut a little bit more in that, those of you who have worked with him, I need you to tell me if actually my observation is right or not. That excellence in Krishna is a beautiful, powerful simplicity and a straightforwardness to things. The way he thinks, the way he talks, the way he approaches issues, the way he looks at very complex systems, the way he deals with colleagues, something I enjoy. I probably envy the times that I didn't have that. And that I cherish in you, and I congratulate you one more time, and we're all proud to call ourselves your colleagues. Thank you.
Before I introduce Krishna, I wanted to take this opportunity to thank the members of the departmental staff and the members of the staff and the deanery who have worked tirelessly behind the scenes to put this show together. So let's give them a big hand of applause. Not everyone who wanted to come today was able to join us. One of them is Ian Patterson, one of Krishna's program managers at NASA, who sent him this card, which I will read now. Dear Krishna, it's an honor to have worked with you for so many years through grants and SBIRs. You are a wonderful person, and it thrills me to hear that you were awarded the Board of Trustees Distinguished Professor title. I know you have touched many lives, and I'm so happy that mine is one of them. Congratulations. We also have a short video presentation in the form of a tribute prepared by former students and some others.
Wow.
Hi Dad, sorry I couldn't be there, I'm traveling this week, but I just wanted to say congratulations on your Board of Trustees Distinguished Professor Award. Congrats.
Dear Professor, it has been really an exciting journey, and I'm really fortunate to have you as my advisor and as my mentor throughout my career journey.
Hello, Professor, this is Cho, long time no see. Congratulations on your achievement as a professor. I always miss the time when I studied with you, because for any difficult and complicated problem, you give us solutions, and you always sacrifice your.
Congratulations, Professor. Distinguished Professor title. You truly deserve the title because you are not only a great scholar, but also a role model for all your students. Personally, I have deep admiration for your patience and caring. It's an honor to be a part of your research journey. Please stay healthy. Bye. Bye. Bye.
Hi, sum you up in one word, commitment. You are very ideal. You always motivate us to work really hard, and I'm very, very blessed to have you in my journey. Thank you.
Congratulations, Professor, for getting the prestigious Board of Trustees Distinguished Professor title. It's an honor for me to be part of your research here.
Dear Professor, many congratulations on receiving the Board of Trustees Distinguished Professor title. You are a great role model for many engineers and researchers around, and it is my privilege to learn from you and be a part of your journey. I wish you very happy and healthy times ahead. Congratulations again. Bye.
Congratulations, Professor, for the Board of Trustees Distinguished Professor Award. It has been a really rewarding and life-changing experience for me to be a part of your research journey, and I feel really fortunate to have you as my advisor. I cannot thank you enough for all your guidance and support all these years. Wish you good health, happiness, and lots of interesting research problems to work on in future. Take care. Bye.
Congratulations on your new award, Professor. I'm glad to be a part of your lab. You make a great role model and teacher, and this honor is well deserved.
Professor, on behalf of all current Cyber Lab members, we'd like to congratulate you on this well-deserved achievement. We admire your hard work, dedication, and passion. Congratulations.
I have known Krishna as a professional.
Sorry.
He has the last word.
He came for the real one.
I have known Krishna for over 3 decades as a professional colleague, and even then, he never ceases to amaze me with all the contributions that he makes to our educational and research programs in systems engineering. In 1993, he co-founded a technology company, Qualtech Systems, which is now a thriving enterprise. So if Krishna just wanted to pursue research in this field, he could do it without needing an academic appointment. But it is this desire to instill the same passion in his students that he feels for the field that propels him as a professor, for which both his students and I are grateful. The term world class has become a cliche, but when it comes to Krishna, everything he does measures up to the highest standards. As he says, if he's going to do it, it needs to be done right the very first day. So ladies and gentlemen, let's join together in welcoming Krishna Pattipatti.
Thank you very much. First of all, I was really surprised to see my daughter yesterday. I didn't know that she was coming from London. So that's, I think maybe two days back, I think Mary asked me, hey, if your kids are coming any of your kids coming for this meeting? And I said, no, I just saw her about 3 weeks back in Edinburgh. Both my son, daughter, and my wife who were there. And I think she already exhausted her vacation. I don't think she's coming. So yesterday, I suddenly saw her in our house, and so that's a big surprise. Thanks for coming. And another person I want to thank for coming is Nils Sandell, who was my first and only boss outside. So thank you for coming, Nils. And I didn't expect Dave Kastner from BU. Thank you, David. First of all, I want to thank my students, Manisha and David Sidoti, who helped me with this presentation, because they know that all my students know that I'm a technologically challenged person. I can't get anything done, right? So thank you for doing this. And also, I would like to thank Peter Willett, I don't know where he is. Peter? And also Mike Corsi and Rajiv for making this nomination possible, and also all the referees. Thank you again. I see Michael McQuaid. Thank you for coming. I guess Mike was one of the referees, so thank you for writing a nice letter for me. And also the committee for selecting me as the Board of Trustees Distinguished Professor. I'm honored for this title. And it has actually been a very rewarding journey for me with UConn as a graduate student and at UConn as a professor. If you know me very well, at least the people that are close to me know that I really shun publicity. That's why I've been avoiding this particular speech for almost a year. But I wanted to do it in my own way. So that way is, I want to basically take this opportunity to express my gratitude to many people. So those many people include my parents, my teachers, both here as well as at IIT, and also my colleagues, many of them from Alpha Tech, and you saw one of them, Ann Patterson-Hein from NASA, and also several people from Office of Naval Research, and especially my students, because I feel that without students, professors are nothing. So the graduate students are the ones that make you what you are. When I was preparing for this talk, I wanted to see what really shaped my life, and it turned out to be three things. One was my education at IIT, the second was my education at UConn, and the third is the 6 years I spent at Alpha Tech, because that's the only place I ever worked for in the industry, and that basically set the stage for all my future research. You hear a lot about it takes a village. That's actually very true for me over the years. And you'll see why and how as I go through my presentation. And I also want to convey a few life lessons to the graduate students, because hopefully they will learn something along the way. Okay, I actually came from a very small village, about maybe 562 people in 1970. And we didn't even have electricity till 1973. That's, as a point of reference, I came to UConn on August 24th, 1975, just basically 2 years before. This picture was taken in 1986 when my parents were visiting the United States. It was about maybe 7 months before my father passed away. I feel that this honor is primarily due to my parents' hard work. My mother basically used to take care of the fields. I came from a farming family. She's about 96 now. And even now she always is doing something. And my father used to dabble in business. One of the great things about my father is that he had a passion for educated people, education, and he always wanted all the children to be educated. And in fact, that he was actually discouraged by the people in the village. Those days, education was not that important for people in villages. And one of the great things about my father was he always used to invite educated people to our house. And any books that they recommend, he used to buy them. And typically, those people tend to be from cities and high schools. So they used to, basically, when he bought those books, they tended to be different from the books that I used to read. And that actually gave me one life's lesson, that is, hey, you need to get information from different viewpoints. And that is exactly what I do as a teacher. I try to synthesize my lectures from lots of different sources and have my own way of doing things. And that's what I recommend to all the students. So whatever little success that I had, I owe it to my parents. And I come from a very small village, as I said. I used to basically walk about 3 to 4 miles to school. And after high school used to be those days ending on 11th grade. So you do need to do 12th grade before you can go into professional courses. So I did my so-called pre-university course about 160 miles from my village. Then I went to IIT, IIT Kharagpur. So I would like to say a few things about IIT. It's quite competitive to get into. I don't think I can get into IIT now with the competition that's going on right now. One thing is I got probably the best education at least in my view, mostly with merit scholarships. My parents must have spent maybe about $200, that's cumulative over 5 years. And in contrast, I spent like $200,000 for my son. Okay. And that is only his undergrad. So for the graduate education, he went to Harvard Business School, and he was rich enough that he paid for himself another $200,000. So we need to do something about the cost of higher education in this country. The second thing is, I had actually gotten into IIT 2 ways. One is through the entrance exam. The second is I was actually first in my university exams. So I got into this electronics, like Fakir Jains. So I told him that I'll be insulting him. So electronics is something that I hated.
That's why you are technologically challenged.
Right. So, but the thing is, at IIT, the best teachers were not in electronics. The best teachers were in electrical engineering. And so one of them is pictured here, Professor M. Keshavamurthy. He taught me signals and systems. So after I took that course, I was hooked on to systems theory. And I'm glad that I also came to one of the best schools for systems. That's UConn later on. So this was a picture taken in 1983. My wife is actually multilingual. She can speak a lot of languages. And it turns out that this teacher is, he can speak Tamil, so my wife could converse with him. And we used to fear these teachers at IIT. But outside, he was such a nice person that once we got to know him. So he's probably the best ever teacher that I ever had. Also, if you look at the picture, the one on the left was the picture that was taken for my passport to come to this country. And you can see on the right what USA has done to me. Okay? So I got into 2 universities because I couldn't afford application fees. And one of the nice things about UConn those days is that they used to waive application fee. And it was quite easy for me to decide at UConn because one of the professors had known about the work that David Lindorf has done on sample data systems. So there was a book in 1960 that he wrote. So he was aware of that. And later on I got to know that actually UConn is one of the best schools for systems theory. Like Ralph Quachenberger, who developed this describing functions, was from here. Although he graduated from MIT, but he was a professor at UConn. And Dave Kleiman, later on I found that he was the superstar in optical control. And of course, Yakov with his multi-target tracking and stochastic control. So I got this letter from Charlie Knapp, who was the acting department head at the time. So they gave me like half fellowship and half RA. It was about maybe $3,300 those days. And you had to pay this out-of-state tuition for the first, at least for the first couple of years, I had to pay the out-of-state tuition with that money. And this is a proof that actually I did get my degrees from UConn. And I'll be saying more about my UConn education a little later. So this is basically my journey from UConn, India to the United States. So at UConn, what happened? So then basically this is my journey and ended with this Board of Trustees distinguished professor. You can see that my son is there on the right, so he did attend the event. So this is the thing that Manisha found, this academic genealogy. So where it originated from, turns out that I originated from Leibniz. Now I know why I used to love this Leibniz differentiation in the integral terms. When I was learning about the modern estimation theory from Sage and Meltzer's book. I only know the people on the rightmost like vertical line. there's Dave Kleinman. Dave was only about 33 years old when I came, and he was already a superstar in optimal control. He actually came up with a solution for the Ricardi equation, quite a few other things. My academic grandfather was Michael Athens. He was a professor at MIT, and he's probably the clearest thinker I've ever come across. He's so clear in his way of thinking and way of presenting things. And I worked with him very closely when we were trying to design test facilities for carrier-based systems, so carrier-based test facilities when I was at Alpha Tech. The only other people I know in this list are William Norton. I think he was a civil engineer and a professor at Yale, and D. Lombard. So he's the D'Alembert principles for finding dynamics of physical systems. But I never liked that stuff. I like the analogy between electrical systems and mechanical systems, using those to find the dynamics of mechanical systems. And of course, there was a controversy involving Leibniz and Newton way back. So in terms of UConn, I really had a great time at UConn. In fact, there was another student called Lou Godbard. I used to share the office with him. Lou was Dave Jordan's student. We actually used to play basketball. So we say that the US versus India. But India always lost. However, I used to be quite good in badminton because Tom, who is here, Tom and Jean, I knew them since 1975. Tom and I, we used to play almost for 3 hours, maybe 3 times a week. And we used to beat almost everybody in badminton. That was excellent time we used to have. And also I knew Radha, who used to be in business school. He also graduated from UConn. And I'll have more to say about him later. Although I was officially a graduate of control and communication systems, I never had any background in signal processing and communication. So whenever I need something in communications or signal processing, I just go to Peter Willett, who is the best guy in this area. I was taught by Charlie Knapp. Charlie Knapp is the best teacher that I had at UConn. All of them were very good teachers. And I learned basically nonlinear programming and numerical computation from Dave Kleinman. In fact, I teach those courses at UConn. And Dave Lindoff taught me nonlinear systems. Dave Jordan, who hired me back in 1986, taught me linear systems theory. I also had a course, so one of the nice things about UConn's PhD is that you need to take courses from outside the department. So my outside department was computer science. Taylor Booth, of the BCAT fame, actually taught me queuing systems. That actually led to some interesting stuff, both at Alpha Tech and as a consultant to IBM later on. And Y.T. Chen taught me pattern recognition. Basically, that formed the basis for my machine learning course. And I don't remember what Yakov taught. So I do remember that we used the Dmitry Butsekas 1976 edition of dynamic programming for stochastic control. But what he taught me is how to drive stick shift on my new Although he claims that I totally forgot. And the connection between him and Radha is that Radha is the one that took me to Worcester to buy that first VW Rabbit that I bought. So he thinks he forgot. I think my wife and children probably agree that I don't know how to drive because she has saved me 3 times from accidents. So. I did an independent study with Bjorn Wittenmark, an amazing person. He came from Lund University to do sabbatical at UConn. And I actually wrote 3 papers with him in 1 semester. So it was very productive independent study, I would say. My master's thesis was on insensitive control or robust control. And that was motivated by this C-5A transport aircraft. And Honeywell was actually evaluating 10 different controllers from 10 different groups. And ours was one of the best, in fact, the best among the 10 controllers. So that was good for boosting my ego. And next thing is, another nice thing about my PhD thesis was UConn used to be very good in something called manual control, using so-called optimal control model. So what that model basically assumed is that if you got very well-trained, well-motivated human beings, for example, pilots or anybody, drivers, they do the best subject to their neuromotor limitations. So they could actually develop a whole theory based on that. And that was actually used in display design and a lot of other things. So one of the things that happened in late 70s is that you started getting these fly-by-wire aircraft, and also the humans started becoming more of a monitors and supervisors of systems rather than actually controlling the systems. So that means that they become more of a decision makers, like basically attending to different tasks at different events at different times. So my thesis was primarily on applying the so-called normative descriptive type of theories to modeling those kind of things, and we came up with a model called dynamic decision model, and that started our whole decision-making research with the Office of Naval Research for the last 35 years or so. Okay, these are the courses that I teach at UConn. You can see that apples don't fall too far from the tree. Only new things that I've done is linear programming network flows. That is something that I learned at Alpha Tech by working with Dimitri Butsekas, who is a consultant. And he taught me everything I needed to know about optimization. In fact, he probably made my career in that field. Another course that I teach with Peter Liu is modern manufacturing systems engineering. So I got interested in robust design in late 80s, and that's how we started introducing. And there's another course actually we introduced on wireless communications with Peter Willett, but we are not expert. At least I'm not expert, because I never had any background. Peter is semi-expert, but we did get an expert in Shengli Zhao. Now he does teaching in that area. So. Okay. So the good applications lead to good theory basically came from Alpha Tech. So Dave Kleinman is actually, was my academic advisor. He basically took care of me over the years. And he's our family friend. So whenever he comes from West Coast to visit East Coast, he comes and consults with us on the Navy projects. So he always stays in my home. So he's a family friend. Right now he's in Tanzania. Maybe the third time I think he's been to Africa. So this guy takes vacations maybe 3 or 4 times a year. And that's actually causing problems for me at home. Hey, how come you're not retiring? So that's a problem with Dick. But he's also a very clear thinker. Nils says, my mother is a hardworking person, so I learned hard work from my mom. Nils is another person. In fact, he gave me an opportunity to learn tracking. Not Yakov, but I learned tracking from Nils because he had a student called Kevin Kavarian, and he gave me his thesis. And that's where I learned what the complexities of the problem are. And so thank you for that. And also opportunity to work in optimization and queuing networks. All I had was queuing systems background from Taylor Booth, but I learned a lot in queuing networks, and that led me recognition with IBM and consulting with them and a lot of other things. Another thing that he also told me is that, hey, be nice to sponsors, especially young ones, because they are going to be the decision makers later on. And that has been very useful to me over the years. Another person that really helped me is Joe Wall. Joe is an engineering psychologist. He actually worked on the Apollo program. He used to work at a company called Dunlop Associates in Connecticut, Stamford. And he introduced me to the whole area of diagnostics and prognostics. And that actually led to this company that we founded, Qualtech Systems. And that has been given me immense professional satisfaction over the years. And another person is Dimitri. He taught me everything I needed to know about optimization. In fact, he's coming on October 23rd to give a plug. He's going to spend 2 days here giving a distinguished lecture. And of course, Mike Athens, as I mentioned, he taught me how to write proposals. So did Nils and David. And also how to make presentations. So those days we had to make them in these transparencies. So the main thing they taught me is that if you start with good applications, they lead to good theory. And nice thing about working at Alpha Tech was that I got exposed to lots of different problems and lots of sponsors. And right now, I get problems from the field, basically. They tell me, hey, this is the problem that we want to solve, and this is the money that we want to give you. I basically write maybe 2-page proposals, and that's that. So that's been very good. So what is the impact of my research? So I've worked on maybe about 6 or 7 areas. That's a nice thing about being in systems, because all you're doing is pushing equations. One area is the humans, teams, organizations, and planning. So that's like, how do you design organizations? How do teams make decisions? And how do you do planning under uncertainty? The second is diagnostics and prognostics. And third is multi-object tracking, where Yakov is the world's best. And computer and manufacturing systems that came out of Taylor Booth's thing. And wireless communications. I owe it all to Peter Willett. I'll explain that. And battery management systems, and also more recently in autonomy. So what is common among all these things? So our problems tend to be intractable, meaning that it takes a long time to do it on a computer, so you better find some solutions that are time efficient. The second thing is complex. That means there are lots of variables and lots of constraints on your problem. And there's a great deal of uncertainty. That means that you need to make decisions in probabilistic domains. So I'm going to focus only on the last 3. So let me briefly talk about this wireless communications. So one of the problems in cellular telephony is you've got all these messages that are coming on some channels, and you need to unscramble them. That's called demodulation. So one of the things that Peter Willett came one day and said, hey, this is this problem, where you probably can make good contributions. So I said, I don't know anything about wireless communications. It turned out that that's basically a problem involving either binary least squares or least squares with some discrete set of variables. And what we did was use this so-called probabilistic data association concept to convert this intractable problem into some polynomial problem. And that whole thing was done maybe in one afternoon. So I worked with Peter and another student of mine, G. Luo, Rocky. He's actually a professor at Colorado State now. And it turned out that it worked so well compared to the other algorithms that were there in the literature. So although I'm not a communications expert, we happen to make quite a few contributions to that area. I think we wrote maybe at least a dozen papers in that area. The one in computer systems was a project I talked about earlier on this design of aircraft-based automated test facilities. And one of the things, if you remember, during President Reagan's time, there was something called Star Wars, a strategic defense initiative. I remember Nils and I going to Rome Labs, and we convinced a person named David Trad to give us money to develop models for fault-tolerant computers. So how do you evaluate the performance, reliability, performability? That's basically performance of a system that is subject to failure. So what are how do you characterize the dynamics of such a system? So as we started working on this project, we found that the queuing networks actually were intractable problems in the sense that it used to take exponential complexity to solve them exactly. And there were some approximations called Schweiger-Bord. Schweiger is a professor at the University of Rochester, and Bord was at IBM. And also Chandy Noyes. Chandy used to be at UT Austin, now he's at Caltech. but they never proved that they actually converge. So one of the things that we found is that, hey, these are basically nonlinear set of equations, and they happen to be the gradient of a convex function. So that, as and asymptotical at least, and you could prove all sorts of interesting things using that. The second thing is with the performability for time-varying systems, you could actually represent them using so-called hyperbolic partial differential equations. And that work I did with Henk Blom, who came to UConn to do his PhD. And then he took my course on linear programming, I think. And I give a lot of homework. So he said, no, I'm not doing my PhD here. So, but Henk Blom is well known for his interacting multiple model approach. And he also pointed to me the literature on something called piecewise deterministic Markov processes that was done in control theory. And we had fun time developing a lot of the theory for that. On the battery management systems, what happened was that in 2002 or 2003, Toyota had come to us to do work in the diagnostics area. In fact, they evaluated lots of companies, a lot of universities, including MIT and other places. And they selected us to work with them for maybe about 7 or 8 years. So one work that we did was how to model the battery from basically health and also battery state of charge for the Freedom car, where we could get the data from Idaho National Labs. And Fairchild saw that work and said, hey, we want to develop state of charge, state of health estimations for the lithium-ion batteries. Can you help us? So that actually, we worked with Yakov and Bala. He's at University of Windsor now. He used to be our postdoc. And that led to a whole series of papers that are widely referenced. Okay, so I want to briefly go through the 3 research areas. One is the team decision making. So the motivation for this is the following. So with the success of chess and Go, another more significantly what is happening is that you can have even novice players with computer help beating grandmasters now. There have been cases like that. So the question is, there's an increasing interest in hybrid teams. Those are the teams with machines and humans together working on a particular task and a problem. So what are the kinds of problems that we have? Can we exploit the strengths of machines? So what the machines do, they can basically do deliberate processing as well as they can do basically instant recall, unlike humans. So I had to struggle to remember, but the machines can recall instantaneously. However, the humans have this creativity, adaptivity, and learning capability. So can we merge the two? Can we have man-machine symbiosis in structuring such hybrid teams? So then the questions are, how do you allocate tasks between humans and machines? How do you learn in a new environment? And what tasks and functions to automate, at what time, at what level? And you can see all those applications in autonomous cars and a lot of other things. And also, how does the automation let the human know what it's doing? And how can it actually figure out what the context of the human is? Is he working hard, for example? So we're actually doing some work on using eye tracking, pupil diameter, gauge type of data to figure out the human context. So one of the key problems here is to build up a harmony and a fit between human network, machine network, and the task network. And it turned out that there was an effort by ONR that was started by Bill Vaughan, who was another mentor of mine at the Office of Naval Research, way back in mid-1990s, called Adaptive Architectures for Command and Control. And some of my PhD students actually worked on that stuff. Andras Pett, who used to be who is in Hungary now, and the two Levchuk brothers, I see Georgi and Yuri Levchuk, and several other students. Feli was also one of them. They developed these algorithms for robust and adaptive organizational designs. Right now, it turns out there's a big DARPA program and structuring and task assignment in these hybrid teams. And Georgi is leading one of the teams to basically do that problem. And he's using like factor graphs and the thermodynamic concepts of friction, energy minimization to design these hybrid teams matched to the tasks. So this area has been about maybe 35 years of worth of work that we have done, and Office of Naval Research has been continuously funding us in this area. There was a program that was started, something called Distributed Tactical Decision Making, that was started in '84 by, again, Bill Wan, where Alphatech was the prime, and UConn used to be the subcontractor. I used to be at Alphatech at the time. And Peter Liu and David were the ones that were doing the work for UConn. Then when I came in '86, I started working more on the inference or even detection type problems, whereas Peter was working on the resource allocation problems. And so we came up with the so-called TROC, which is a team relative operating characteristic of how to characterize an expert team in even detection type tasks, and also all the work on organizational design. Right now we're involved in quite a few operational problems, such as ship routing for minimizing the fuel, and water space management. That's becoming very important with a lot of the accidents that we've been seeing recently. The second area is fall detection, diagnosis, and prognosis. One of the problems here is you need to be able to detect that there's something wrong. That's the anomaly detection or the failure detection. Then you need to diagnose. That involves basically 3 steps. What is the root cause? Where it is located? And how severe the problem is? And also the prognostic. That means basically you want to be able to detect problems early on and continuously keep track of how much remaining life is left in each of the systems. So with the network systems, this is becoming even more important. For example, how do you design a way of architecting these failure detection and diagnosis and prognosis type architectures for systems? So you can think of it maybe any cyber-physical systems, such as buildings, automobile, or aircraft. You have a set of monitored variables that come from sensors, and you compare with some nominal values that could be model-based or just comparing with what you expect. So those are called residuals. And based on those, you do a statistical test to determine what the whether something is wrong. Those are called error codes. And those could be correlated or fused to figure out where the problem is, and then estimate what the fault severity is, and then do something about it. So depending upon where you put your network, for example, if you put the network at the monitored variables, it will become remote data acquisition, then everything else is being done in the cloud. If you were to put it at the end of test outcomes, basically you send only the error codes. So you have smart sensors, you send error codes to the cloud, that will become telediagnosis. If you put your network at the diagnostic decisions layer, basically your system has got intelligence to make its own diagnostic decisions. If you put your network there, it also can do the prognostics. So what we've done over the years is developed a series of theoretical as well as software for design for service, the architectures for that, and remote onboard monitoring and diagnosis, maintenance at the customer side. You can have networked multi-level maintenance that you could access the internet, and of course all the data is being logged for knowledge management, maturation, adaptation. So, and we have done these diagnostic models using physics-based models, just based on data-driven models, as well as knowledge-based, such as graphical models. So this work actually started in Alpha Tech again in 1982-83 time frame, when Joe Wall went to a conference and he saw some people from Airing using some information theory-based approach for troubleshooting. And he came back and said, hey, let's start some IR&D program and see whether we can improve on this thing. And that's how I got into this area. And what we did was we combined the so-called heuristic search from artificial intelligence with some information theoretic concepts of coding to get so-called cost-to-go information of dynamic programming. And you can do forward dynamic programming and solve problems that you cannot solve using backward dynamic programming approaches. So that won some best paper awards, and then that also got into some phase 2 SBIRs at Alpha Tech. By that time I had to leave to come to UConn. And we worked with Sikorsky aircraft on the Comanche program. And then the Sikorsky people said, hey, we need the support for this thing, so go develop the software and support it. That's how the CSI was established. And they applied it to NASA space stations. As we said, we've also worked with Toyota, General Motors, and we also had some programs from NSF in this area. And it's being used for the Mars program. The third area is the multi-target tracking. This actually started out as a consultant gig with Alpha Tech. In fact, I worked with another UConn student, Haralampus Takanakis, who used to work at Alpha Tech, and also Bob Washburn. Chaknakis was a student of Tiza, who was a professor at UConn in communications. So the problem here was the following. Suppose that I have only direction finding sensors. That means all I know is that something is there, there, and there. And I've got multiple sensors. So if you've got only two things, and if you've got n targets, even if they're perfect, it's going to intersect at n squared different points. So you will get n squared minus n ghosts in addition to the n real targets. So you need to have at least 3 different sensors in order to be able to locate those. And if you've got uncertainty in those measurements, then the problem becomes a little more complicated. That's where the uncertainty comes in. And that becomes something called the 3-dimensional assignment problem. And that becomes an NP-hard or so-called intractable problems. So what we did was we came up with a way of solving it polynomially, and I'll explain one of the techniques that we used. And this kind of problem arises in a lot of other applications. For example, you can have multiple targets and multiple sensors as I have here. You can have active and passive sensors together. You can have a single target, but you can have multiple frames, multiple time slots, and multiple targets, multiple sensors, and multiple time frames. So you can actually have a huge problem of matching lists from multiple lists. And this could be as high as maybe 20 or 30 lists that you may have to match in some cases. So how do we solve problems like that, where the complexity basically explodes? So this problem, we first came up with an algorithm for the 3-dimensional assignment, as with Somnath Deb. So notice that the SD stands for Somnath Deb. We didn't realize that he was sneaky. So he called it S-dimensional assignment, where S is more than 3. And we didn't know that he was actually putting his initials there. Then we also had this guy, Bob Pop, work on parallel 3D and invest assignment. Bob Pop is, he worked for DARPA. And also, more recently, I worked with Dave Castnon and my student Lingyi Jan on a very interesting problem that somebody gave us, a nuclear loading problem. It's got nothing to do with tracking. And there, the problem was to find maybe 10,000 best solutions in less than 10 minutes. We were able to do it in about 50 seconds. So that is a recent paper that we got published. So in terms of the other timeline events, my thesis was on the DDD, as I said. Another thing that I'm grateful to Joe Wall about is that he was responsible for this outstanding engineer award. That's the 100th year of IEEE, 1984. And it turns out that at that time there were only 33 societies. And 3 of them, guys representing different societies, were from IIT Kharagpur. And those are the only 3 from any IIT. So there's a lot of competition among the IITs in India. So I'm proud of the fact that all 3 were from IIT Kharagpur. And I was made editor-in-chief in 1998 after Andy Sage retired. And we had 2 NASA Space Act Awards, one in 2002 and 2008. I'm grateful to Ann for that. And we actually got about 9 Best Paper Awards in testing. So the 9th one was in 2011 or so. And the UTC Institute, I'm very grateful to Michael McQuaid for making it happen. And of course, our previous dean, provost, and now the president of Missouri University System, Mun Choi, and my dean, Kazim Kazarani. It was a pleasure working with all 3 of them. Okay. I had actually several academic options when I was leaving Alpha Tech. So maybe Alpha Tech was viewed so highly that I was actually offered a job on the phone without even an interview. And I should also say that even at Alpha Tech, I was offered a job without an interview because Dave was one of the founders of Alpha Tech, and he says one day, hey, let's go to Boston because there's a party for my cousins or something. And I go with him and said, hey, let's drop by Alpha Tech. And Nils calls me and gives him an offer. No interview, nothing. So I'm quite happy with that. That's something unique. So I had several other academic options, both on the West Coast and Boston and also UConn. My choice was very easy because I know the people. One of the great things about systems group is that it's all teamwork. We collaborate a lot. And one of the things is Yakov had already put me for 1 month of summer, even before I came. David had put me for 1 month of summer before I came. So all I had to do was get 1 month. The department said, hey, well, we'll give you 1 month summer salary. But I didn't even have to take that. So maybe I'm one of the few faculty members that didn't take the money from the department. I got my own contract by spring from Harris Corporation. And that was that. So I never had to look back. So teamwork is what I cherish at UConn. And if you take a look at my publication record, basically a lot of them are joint stuff. So the guy that have written most papers, both journal conference papers, is of course Dave Kleiman, who used to be here, and Yakov. We did a lot of work together in multi-object tracking and battery management systems. And the 2 Peters, so Peter Willett and wireless communications. I didn't think that we had written that many number of papers, but he also works on multi-object tracking too. Wireless communications, we have an expert in Shanghai, so we had 4 papers. Many of them are actually student projects as part of my either machine learning or optimization courses. So I don't give exams, but they have to do a very substantive project. And it turns out a lot of them actually lead to either conference papers or journal papers. In fact, 3 out of those 4 were journal papers. And I also work with younger faculty, Ashwin Dani and Shalab Gupta. All right. As I said, the students are the ones that make you look good. And these are my PhD students. Many of them are distributed in the East Coast. About 3 of them are in Connecticut. Many of them are in Massachusetts. The first one is Georgie. Second guy is Bob Pop. Since Bob is not here, I can say bad things about him. He came with the torn jeans to me and Yakov, so we picked him up. He was in computer science, actually. And
we rescued him.
So he did an outstanding job implementing some of these algorithms. And then he worked for Alpha Tech a bit, and then went to Pentagon, and then from there he went to DARPA. Hain Tu, who is here, Mosde Shakeri. She used to work at MathWorks. Now she's doing a program at MIT. Vijay Raghavan is a senior manager at MathWorks. Luo is also working in Boston area. Most of my students seem to be entrepreneurial. Like for example, Somnath runs Qualtech, and also Bob Cobb has got his own company called NSI. Bo Tang was my actually first PhD student, and I had actually 2 husband and wife teams. One is Hai Tu and Luo, the cross diagonal ones, and also Fei Li and Fang Tu. They're in Washington. One works for Expedia, other works for Microsoft. And we also had 2 brothers. One is this guy, Yuri Levchuk, and also Jordan. Both of them are actual brothers. Okay, one of the things about some of the things that Dave taught me. Now, Dave is very stingy when he writes his code. In the sense that he needs to get all the efficiency he could get from the code. And I'm like that too. So the guys that really have that tendency are the Vijay Raghavan, the guy that works for MathWorks, and Somnath, and 2 of my current students. These guys are so bad that they fight even for microseconds, which is Vinod and David Sidoti. So that's good. And we had a total of 25 PhD students. 5 of them work abroad, 26 right now. And 3 more are going to graduate this semester. That's Manisha, David, and Vinod. So we'll have 29. And I have 6 more to graduate before I be forced to retire by my wife. In terms of masters, I think I have 37 master students. And the thing is, these guys are, some of them have become multi-millionaires, and most of them basically work in the industry or have their own companies. So I would be remiss if I don't acknowledge NASA and the Office of Naval Research. Ann Patterson-Hein, who I've known her since 1993, she was instrumental in establishing a cooperative research agreement between UConn and NASA. We never had such a thing. And she's actually helped us develop a lot of interesting algorithms. I think some of the work that was done by Mosde and Raghavan was funded by her. I've come to know both her and her family. In fact, we talk about her son a lot. And she has become a very dear friend over the years. I briefly mentioned Bill Wan. Bill was a guy that actually trained special operations people. And he used to run the Neurocognitive Sciences Division at ONR until 2006. And Jerry Melek is a true gentleman. He has made my career in a way. And he was so nice to me that he used to take me to all these Navy clubs for dinner. So I used to get this special treatment. So that was very nice. Both Bill and Jerry passed away maybe within 1 month of each other in 2014. So I really am grateful to their contributions to my career. Jerry also introduced me to Jim Hansen. Jim is a very interesting guy. He's a Rhodes Scholar and a former MIT professor in oceanography, and he's a superintendent at NRL Monterey for the Marine Meteorology Division. He's actually the captain of the football team of the University of Colorado that won this national championship in 1991. Apparently that's the only time that they ever won. And he's very famous for this so-called PARS, which is the Pirate Attack Risk Surface, which is an intelligence and weather-based product that the US Navy uses to anticipate where pirates might strike. And you see that you don't hear too much of that these days. So that's one of the reasons. And Jeff Morrison, actually, he took over from Jerry and has been supporting our work and has been a proponent of transitions of our research to the Navy. So next I wanted, maybe I don't know how much time I have, 5 minutes? Okay. So let me just put my research into this context of data decisions. And so if you go take a look at anything from the census to the decisions that you make, the data tells you what do you know. You would like to figure out what happened and why did it happen and what could happen in the future. That's basically predictive. And what do you do about it and what does it all mean? It's a semantic. So this is how the data decisions works, and that's what people actually use in machine learning and data sciences. So if I go take a look at our research, basically team decision making and military command and control is basically in the upper level. And our work on diagnostics and tracking, you can think that is basically what happened, what could happen. And our work on machine learning that we do is basically the first 4 blocks. Okay? Namely, what do we know, what happened, why did it happen, and what could happen. Okay, so how does our research distinguish from other ones? So we primarily work with hard problems. So hard problems are like huge search spaces what you have. It's like finding a needle in a haystack. So there's a very nice cartoon from Gary and Johnson. So suppose your boss comes to you and says, hey, I want to build this new product. You can say that, hey, this problem is so difficult that I can't find a solution. I'm just too dumb. That's not going to be very good for your job. Or you could go and say that, hey, this problem doesn't make sense. There is no solution for it. That requires you to have a lot of mathematical background to actually prove. And the third way is that, hey, this problem is so difficult actually that I can't find a solution, but none of these other famous people too. So that's basically our problem. But fortunately in engineering, don't say that, hey, it's so difficult. So you may not find a needle in a haystack, but there are lots of needle-like things in the hay. So it will be nice to know how close this needle-like thing to the actual needle. So you need to have a measure of distance from the needle that you're really interested in versus the needle that is sort of like a good enough thing. So those are the kinds of solutions that we work with. And what those things do is, the one at the top is unimplementable solution, so-called dual solution, or relaxed solution, and where you really cannot implement that one. That means it doesn't satisfy all the constraints. But there may be one that is actually satisfying but is not good enough. So what we do is we iteratively make these two things approach each other. And we'll also know how bad you are. That's what is called the approximate duality gap. And if ever those two guys meet, you know that it is optimal. Because one is unimplementable, one is implementable. Implementable and unimplementable are the same, means that you're at the optimal solution. So that's one of the concepts that we use. In fact, I could treat this whole thing as sort of like my matching problem that I talked about. So we have used things like the one with the primal dual is basically decomposition and relaxation. That means you decompose a very complicated problem into simpler problems and use this so-called primal dual type concept. The second one that has been very useful for us is what AI and computer science people do is modeling and search in very large graphs. That's sort of like what chess and Go things are. And dynamic programming, which is what I call the principle of optimality, the principle of life, which basically no matter where you are or at what state you are in, you do the best you can in the future. That's the way that you should be living your life. So unfortunately, what it requires is to evaluate all the possible ways that the future can evolve, and that becomes intractable. So what we do is approximate dynamic programming. Again, a concept called rollout is the one that we use a lot. And we also found in the performability and also any markup type things, the so-called dual systems of equations, one forward and backward type of things that we have used a lot. And machine learning is another thing that we use. These are various applications that we worked on, and also the different algorithms that we have used. And what it is basically one of matching these things for different applications and different algorithms. So we basically developed the third part to suit a particular application using some of the concepts. So let me skip some of these things, because now that people don't have time. So what I want to do is I want to leave the people with key life lessons that I want to get across to the students. One of the things that I found is that keep the inquisitiveness alive, right? So even now, right, when I have a problem, basically, I turn it around all sorts of ways that I look at the problem, or go look at the literature and try to figure out a solution, right? So you need to have that inquisitiveness. That's what I tell my students, that hey, you need to be always trying to solve the problems, or always looking for new ways of solving problems. The second thing that I say is attention to details is very important. So, for example, this presentation, I think UConn Dropbox must be crying because we went through back and forth so many times, so many iterations of this. And any paper that my students write, they go through at least 20, 30 iterations before it actually goes out. That means you rather find the problems in-house than somebody else finding the problems. So link up with people with high expectations. So I feel lucky that I got to work with people that have very high expectations. One of them is Yakov. He can be pain in the neck in terms of all the criteria that he puts forth for PhD students. But
that's a professional affliction, paying attention to so much detail.
Right. So I'm glad that I'm associated with people with high expectations and high character. So that is very important. Hard work always pays off. Again, thanks to Nils and my mom. And squeeze every bit of efficiency from code. Write, revise, write. Better to find errors at home than outside. So you don't want somebody else telling you that something is wrong. Look at this, is sort of looks like my cyber lab, right? See. So take care of your sponsors and they'll take care of you. So I never had to worry about funding and all that stuff. Even yesterday, Jim Hansen came and said, hey, we want to give you more than what you asked for because we want you to solve other problems. So if you take care of them, they'll take care of you. So you need to make them look good. And again, Nils advised that be nice to your customers. Do what interests you the most. In fact, this is what I tell, I'm actually the honors advisor for my department. That's what I tell my students. Hey, do what interests you most till you're 30 years old. You don't need to make decisions till then. So you always do what you like. And that's what I've told my children too. Finances will basically take care of themselves eventually. I don't think I ever had major issues with that. When learning a subject, get multiple viewpoints. Strive for clarity and understanding fundamentals and papers. So don't believe everything that you read or everything that you hear also. So always be incisive in your criticism or in understanding things. So that's very important. Strive for clarity and understanding fundamentals. And take care of the students and people who work for you first and then you. So for example, if you have got more students than the funding, you take care of your students first before you take care of yourself. And that's what I did, because I know Dave Kleinman is already rich. So we had him in my ONR things, and know the UConn research people said, hey, how come he's there but he's not getting paid? So I copied Dave, I copied my ONR sponsor and said, we have been doing this. And Dave sent me, that's very nice. So, and even the ONR sponsor knows that he's very happy with what we do. And I told the UConn that hey, our value system is the little guys first and then you take care of yourself. Right? And that's it. So in terms of the research impacts, we basically had optimization applications on the right. So those are all the various sponsors and companies that have benefited from our work. The one on the left side is all INFERENCE, which is basically diagnostics, prognostics, and machine learning type of things. Those are the NASA, General Motors, Toyota, NSF. Those are the people that we funded our work. Fairchild, Pratt & Whitney, we've worked on their engines, Sikorsky on their helicopters, and even Comcast on some video quality and things like that. And of course, QSI. I cannot get any money from QSI, unfortunately, but we have given money to Peter Willett and other people.
With all the key life lessons that Krishna provided at the end, I am assuming you don't have any questions for now or for later. But if you do, I highly recommend taking this course in the spring semester. Thank you very much.
I don't know. Question? I'll look it up. Okay. Yes, man. How are you? Very much. Nice.